Good afternoon, everyone. Thanks for joining this webinar. I'm Namdeo Pawar, working as a senior DevOps engineer in Ksolves. I'm very excited about this webinar because what we are going to cover, that is the actual what my team is doing in day to day in production. Okay, so let me share my screen and start with the webinar. Hope my screen is visible to you. So today's webinar is on Argo CD. Okay, not Argo CD. It's automating Kubernetes deployment with LLM-assisted CI/CD. In this webinar, we are going to cover how AI can help you to deploy, make it automated in deployment parts. Okay, so in this webinar, we are going to do more practical things, less the things that we are going to discuss about the theory. Okay. So today's quick agenda is GitOps fundamental AI-assisted Helm, how we can generate a Helm chart using AI, how CI/CDs we can do automation using AI, how AI can quickly write those things like manifest files or CI/CD files, how drip detection will work, auto PR creation, how human will make it the right things to deploy, and guardrail and best practices. Okay. So let's talk about let me before starting that, let me ask you a quick question. How many of you have been like on a rotational call and where someone asks you at 2 a.m. like what has been deployed, how deployed, who deployed? These are the real questions, okay? But no one knows about answers. Like do someone is doing SSH, doing deployment, right? So here is the things like uh, that manual repetition. Like we are in today's webinar, we are going to discuss about Helm chart, CI/CD pipeline, config drift, and slow onboarding. These are the four pillars of GitOps. Okay, let's move forward with the next things. Like what is GitOps? So GitOps is a single source of truth. Everything lives in Git. Manifest, config, policies, no exception. Second is declarative, not imperative. So it would be a whatever the things that we define should be declarative in the Git, like describes like whatever the controller, manual kubectl apply, nothing would be there. Okay. Third is auto reconciliation, like cluster continuous syncs to a Git steps automatically. And fourth is audit trail and rollback. So whatever like we did, that would be a audit trail. It stores in Git. Like everything that store as a version and every action would be logged in our Git. And it would be very easy to roll back safely. Okay. So these are the GitOps tools, Argo CD, Flux. Those are the CNSF graduated tools that. So in this webinar, we are going to cover the Kubernetes native, okay, which is excellent at drip detection and control plane with beautiful UI. Also, Customize is a Kubernetes plugin that supports to do the templates based on production environments, staging, QA, dev. So according to that, we use the Customize for defining bare minimum things, the minimum things in base value, and others based on our environment. And Helm chart. If you know about Helm chart, it's a everyone would be aware about the Helm chart, but if you know, it's a package manager tool. Okay, in Kubernetes. So we define manifest file configuration. These are widely adopted in Kubernetes, and most of the production, all of the application are going like those are deployed via Helm chart and mostly adopted. Okay, so this is why GitOps plus AI Pro combo. Like AI has a strength. Okay, like it detects the patterns, do the templating, write the manifest file, right? Second is boiler code. Suppose you have multiple environments. So based on multiple, we have same things. So the base is same. So it creates a boilerplate for everything, right? Consistent naming and structure. Understand YAML schemas. Like YAML is very it's a scripting language, very sensitive. If we did some single space, it creates errors. So it would be very hectic to debug that. So AI can quickly write those, identify those, and fix those. Iterate on feedback fast, like it iterates on feedback, like whatever the prompt that we pass, that will be like quickly adapt and AI can work on it. Okay. So GitOps safely net, talking about the GitOps, like AI is an output lands in Git first. Okay. So everything will be in Git, and there will be a human, like one any senior or a manager that can review whatever things we are going to deploy before we directly push. Okay. Human approval gate, there will be a human who can review things. Once if like all the things are in green, then we can only push, otherwise we can tweak on that. The OPA, OPA blocks, like whatever the things that we are pushing should be good. Okay. We are like, suppose we are deploying application over that pod, we didn't refer the resources limitations, the other things that needs to be there. So if that thing we can define, and that could be blocked while like doing this. And full audit and rollback trail, like we can easily roll back. There will be logs in Git who has pushed who has pushed is like whatever the things who has pushed, that would be get logged in Git, and rollback would be very easy, like single command will roll back everything. Suppose we have production, and we mistakenly push something that shouldn't be there. Okay. So doing something live, debugging something on live production, instead of that we can quickly roll back. Okay. So in this here, this is the common example, like how Helm and custom pattern works. Like Helm chart, we like inside Helm chart we define all the manifest, like deployment services, ingress, config maps, secrets, and other like services over there. And in this customize, we define a base values like generic, like related to port, health, images. Like for my application, how I'm going to measure the health of application, it would be up or not, like that. So we'll get the response based on that. So those base value we can define in one file, and other should be separated according to environments, depending on environments, how many environment we could have, like dev, staging, pre-prod, prod, like that. Based on environments, like I want on dev environment, I'll need a very minimal replicas. On staging, I need near to production replicas. On production, I need high availability, like scaling. If traffic increase, we should increase our pods, like that, like affinity monitoring things. So according to environment, we can add multiple things there. Okay. So let's move with the next thing, like that is deployment walkthrough. So previously we were doing SSH, do the deployment. Like for example, in 1990s series, like there would be a Jenkins server, there are defined service files, and there were hard-coded values like server information or SSH credentials, like that. So now with GitOps, it would be very easy. And talking about the manual path, we like developers or DevOps engineer writes the deployment service ingress files. That takes times, copies to each environment. Like each environment need identical file. Based on this, again we could come with the errors. So manual deployment creation is very hectic, right? And tweak replicas, it's a time consuming. So indentation and commit, wait for you, all those things. With AI assist, only need to describe the things, like I need one Node.js application, want three replicas, it would be production environment with port 3000. Likewise, we can define those. AI will understand our application structure, will create the Helm and manifest file according to that. So LLM generate a valid Helm chart. Okay. Only engineers can review PRs. What are the PRs we have created, that will review. If it's good, then we can merge, and it would be automatically deployed by GitOps. So GitOps continually watches, monitor our Git repository. Okay. So this is config management strategy, like environment specific, that we have discussed. According to a environment, we can separate out the things. Okay. So this is the use case. So it's a simple example, like AI assist help chart generation. Like how I can give a prompt to AI, and it will create my manifest file. Suppose I have Python Flask application, I give a prompt like generate a Helm chart for my Python application with detail of this application. Suppose my application name is payment processor and image like my private harbor registry, replicas for each environment like production, staging, dev, which port I want to use, its utilization, like how many resources I want to give for the CPU, memory, what health endpoint would be there for suppose I am adding liveness, readiness probes. According to that, how timeout should be there to checking out pod is come or not, like HPA. So according to that, how my horizontal pod auto scaling will work, how certain criteria should be there, like after 70% cross I want to add another pod, should be at minimum 2. According to that it will write it. Okay. So this is the use case too, like AI generate CI/CD pipeline configuration. So in this today's demo, like we have already covered, created. So let me walk you through about the architecture first. So we are using Kubernetes cluster, okay, on AWS. Okay, we have deployed Harbor registry on one of the EC2 instance. We are for CI/CD, okay, for CI we are using GitHub Actions. Our project is deployed hosted on GitHub. Okay, so here we will be creating like a talking about the CI/CD pipeline. There could be a multiple stages based on your application and your requirement. We have covered very basic things like build, push, and deploy. So in build, we compile the code, test, like do those testing, like we give some unit test cases, like coverage should be greater than 80, that it would pass to the next stage. Like in push, we'll create the image, like build the image, push to a Harbor registry, tag it, so that tag could be used for the deploy purpose. And lint stage, like after we build the image, that should be have the vulnerability free, right? So those things we have added some basic things. And in Argo CD, so Argo CD already deployed on our Kubernetes cluster, that is continuously watching our Git repo. Okay, that I'm going to show you in this live demo. And pod gated up, like whatever the approval that we pass for the production, so there would be a human touch. Okay, and if it fails, like on Slack, Teams, Gchat, we'll get a failure alert on the Slacks. Okay, on our respective channels. Third thing is you drip detection, auto peer remediation, that things we are going to display. Okay, that we are going to show today. So uh, talking about the AI safety and trust model, prompt as a code. Okay, so for repetitive and same answer for same reply from LLM, because LLM could hallucinate, right? So for that we need reproducibility, like same prod plus model, like it could be optimized, but could be at least at the same. Okay, auditability, evaluation, and team consistency. Like there should be auditability. Like if I add something on the prompt, that should be know about other team members. The evaluation, like we added some more microservices and that needs to be get updated into my prompt. So that prompts would be stored on our Git. Okay, so we are using GitHub, right? So hope my screen is visible to you. So we have stored those prompts, so anyone can use those prompts. Okay, that in live demo I'll show you. And policy as code, that OPA that we discuss, open policy agent. Okay, like suppose I have a deployment file. Inside that deployment, I won't allow to deploy this manifest or pod, that whatever things that we are going in Git. Okay, so I will add OPA, right? So it will check before PR validation, like is PR created with the right things. Like we can also enforce the image registry. Suppose I am using a private repo and someone in Git added the Git like a Docker Hub or any other private repo. So in that case, we should enforce that policy. So GitOps won't allow that. Okay. So let's do some hands-on in live demo. Okay. So we are going to discuss the three segments here. One is GitOps loop, drip detection, and AI generation. Okay. So before that, let me show our environment. This is our GitHub project. This is the sample demo application that we have created for this webinar. This is the GitOps Argo CD which deployed, okay, our on our cluster, Kubernetes cluster, and this is the Harbor repository that we are using. Okay, that is again self-deployed private Harbor registry. And this is the simple application which is currently running. That whatever we saw, this is the actual live application. This is Ksolves Service Operations Center. Currently, if you look at the application, currently we have three services. One is degraded, two are running with two teams. Like one is a payment team, another is a platform team. So in first part that we are going to add one push and that will scale replicas. So it will add some replicas, fix this degraded service and add one more service in that set. Okay. So let me show you that live on this. So I'll just only pass one prompt and it will automatically work on that. Even I could work on this, but let's AI work and fix that. So AI will create the fix this is the degraded service. It will make in running, add uptime up to 99% and add one more service. Okay. So let's what he's doing. He has added one more recommendation service that AI recommendation engine and make update in degraded to running. Okay. It will push. Now our CI pipeline should trigger. Okay. So if you look at here, let me refresh. So we have one commit. Now we are going to monitor, like we will be reviewing whatever the changes that we had did. It has updated replica count and the application version. Previously we were on 1.0.0 version. Okay. So let's look at the GitHub actions. So in GitHub Actions, we have many stages. Okay, first one is lint. Okay, lint and test. So what is it? It will clone the code, my static code, do some sanity check and test. Suppose I am using Node.js application, so it will install Node.js on one of the runner, do some sanity check and push like everything is goes, then it will pass to the next stage. The next stage is build and push to Harbor. So it will clone the code, install dependencies and make a image, Docker image. And that Docker image would be pushed to our Harbor registry. Okay. So again, this stage has been passed. We look for, and the third stage is Helm, like update the Helm chart in our Git, right? So once image has been pushed to our Harbor registry, it will pick the tag, okay, whatever the SSA tag that we have pushed, that would be picked and updated in my Git. So Argo CD could continuously, like Argo CD could detect the drift and will sync up my cluster with the actual Git. Okay. And the fourth one is trigger the Argo CD. By default, it sync particularly every 2 minutes, 5 minutes. But for manually, for looking at like a live, I have added one more step to trigger the sync. And fourth is drift check. So it will deploy my application. So if you look at here, it's in sync. The pods is deployed with 0 minute ago. Okay, just deployed that. Okay, so if you look at the application, the version is changed with 2.0.0. Our notification service is running. Uptime is also updated, and one more service we have added here. Okay. So in this we have saw like one push and like we have scale replicas, ship new features very quickly using AI. Like second, we will test the deep detection. Like suppose I have implemented one shell script. Okay. In that shell script, what I have did, I have added some kubectl command. Okay. That will downgrade my replicas. Okay, to 0. So this will be a drift because this is the imperative command that I'm running. So my Argo CD won't able like Argo CD don't know about it, right? So we should have zero replicas. No, but Argo CD will detect this drift and automatically make it up. So let me show you this one as well. And we will continuously monitor our application. Okay. So we'll look for Argo CD and our application. So let's look at it. Replicas is 9. Look for the C. My bash script has deleted all the pod. Script replicas would be 0. Now these replicas would be deleted and my Argo CD by default or automatically fetch, pull whatever the Git configuration, and up to a Git configuration, it will deploy, it will maintain my cluster state. So it again deployed three pods. So if you look at here, kubectl get pods -name space demo. So those pods are just created 36 seconds ago automatically by Argo CD. So this is the powerful thing that GitOps is. Okay. Let's talk about the third. Like suppose this is my application, I want to write another microservice when like in live config and deploy via Argo CD without touching anything, Kubernetes, without touching any kubectl command or anything. Okay. So I'm going to create one more service and that would be automatically deployed via Argo CD. So let me show you here. This AI will create one more microservice. Currently, if you look at here, we have 4 microservices with 9 replica with 2.0.0 on 2.0.0 application version. So if you look at here, so we'll be having another commit. Okay, so AI is doing adding one more service. So it is adding one more service here. We are giving prompt to this AI. Okay. So currently we have 4 microservices. So it will add one more microservice to our GitHub, and that GitHub will trigger a pipeline. That pipeline will create image, and once that image has been created, the tag would be added in Git, added in our Git, and once that added in Git in a Helm chart, that by automatically gated synced in our Kubernetes clusters. That's how real production cluster are deployed and and managed. Okay, so it has deployed another microservice. So let's look at the CI/CD pipeline. See, just we have deployed one more. Okay, so CI pipeline has been triggered. Looks like we have triggered 2 times. Okay, so mm, let's cover this as a auditing. Okay. So in this pipeline, we'll look for the commits. Okay. So we'll look which commit Git is having. So it's CEFC. Okay. So we'll look into this. This Argo CD is having C810. So looks like it has this one. Okay. Because the pipeline is not finished yet. Because of this it haven't fixed these things. Okay, so let's monitor our pipeline. So it's waiting for Argo CD to reconcile. Looks like operation is cancelled because we have added another microservice. So we'll need to look for the latest one. Okay, the latest one is this. Okay, where lint first 3 stages has been passed and it is triggering Argo CD sync. Sorry. So if you look at the commit, that is this commit, okay? So this commit should be here, FC1A. If you look here, the old pods are getting terminated. By default, we are like in Kubernetes, we are using the default deployment strategy, which is rolling update with zero downtime. Okay. So it's creating new pod. Once new pod is created and healthy, it's terminating, deleting the old pods. If you can also look here. So old pods are getting terminated and new pods just created few seconds ago, like 33 second, 23 second, 44 seconds. These pods are getting created. If you look at the application, it never went down. Currently, we have 14 replicas and 6 microservices with 5 teams. Okay. So the stack that we have used, which is like a GitHub Actions, Harbor, Argo CD, Kubernetes on AWS, zero manual kubectl. Git is the only production interface that we have discussed. The demo that we have looked like we only prepare a prompt. That prompt work, we push to a git, then it create like a, it trigger the CI pipeline. CI pipeline create the image. That image has been pushed to a Harbor registry, and that Harbor registry once pushed, again our next stage of our pipeline has updated the commit in our git, and once that updated, Argo CD detect that drift and sync the servers. So these are the best practices uh, that we should follow. Okay, that we have followed. The critical review gets like whatever the PR that we created should be like review from will be review from senior DevOps engineer, or like whatever the configure and why change, who change, what needs to be changed. That should be review. After that, it would be merged. The policy validation, like automated OPA and Kyber no checks, no bypass allowed, drift review, drift reviews, and the things. No LLM generated secrets. Again, whatever the secret that we have used, that are not stored in Git. Okay. Only reference from external stores. Like suppose we have used Seal secret using AWS Secret Manager or HashiCorp Vault. That should be the right way to use the secrets. Okay. Like for production environment, we should have manual approval, and every merge like a pre-merge checklist, like output matches the required intent, OPA resource limit are reasonable. Suppose someone added the more resource to my pod, so it will fail to create that. So these are the things like image registry is approved, secrets are referenced, health check are appropriate. Based on our microservice endpoint, we should have particular health check endpoints. So we can add other things, like we can add the things that could be related to our application, like liveness, readiness probe, and monitoring based on our health points. Like RBAC is not overly permissive. Changes are like explainable. Like iterative refinement and testing, like multi-turn prompting, like initial request was LLM output Helm chart. Like for this webinar, we have created everything, but we can create the Helm chart. We can only give the in plain English, give the prompt to like create a Helm chart for my application. That will create a end-to-end Helm chart, and prompt will be sent back to LLM, all those things. Like test generation, like a test driven generation, like we can add test cases like YAML is valid or not, based on our application, whatever the things that we have written would be right, create to not, all those things. Security and compliance consideration, like consideration, the risk could be LLM hallucinated or invalid YAML. So we have added validated OPA plus schemas check before the sync, right? For LLM hallucination, we have added we have added the prompts in Git. So LLM could also look for that prompts. If needed, it can update it and use the same for like sensitive data in prompts. So we haven't used sensitive data in prompts. Only like whatever the kube config has been shared, everything that could be by ETOPS. So we don't need to share any security related things here. Drip PR sciently changes unrelated configs. The model changes LLM behaviors, like version to your prompt. Like we should pin your pin our LLM model to our chat. Okay, so what we cover today is GitOps plus AI. Okay, humans stay in control and prompt as a code in essential. Okay, so like Git is your single source of truth, and AI excels at generative boilerplate config, and together you get speed with safety and full auditability. Like human touch for peer review, policy violation, and approval kit. And prompt as a code, we version our prompts, treat them like a source code for reproducibility. Resources and getting started, like tools we discussed, like Argo CD. This is the open source tool that we have discussed. Flux is an alternative of Argo CD that we have. The OPA, that like open policy agent, that kind of know. Helm, that is again open source package manager tool. Customize.io, which is again Kubernetes inbuilt tool. The Cloud API and Open API that we have used for our webinar. So, so thanks for joining. That's all from my end.